morning or afternoon or whatever time of day you're watching this, 7th graders. We are looking at dividing positive and negative fractions today. I know that yesterday was our multiplying, and I hopefully gave you a little bit of a ease on how to feel about that. Telling you that, I didn't like it at first either, but we really got it squared away when I learned to shape, operate, simplify. We're going to practice the same kind of rules today, shape, operate, simplify, and we'll add to our chart again when we come to class. I had to pause for a second there. I was echoing in the classroom with the speakers on. So now we're ready to go. Following along in your book, we're on page 102. So we're dividing today instead of multiplying fractions. Let's see. Why is that showing up? Oh, well, we're looking at inverse operations. If you see on your book on page 102, it says inverse property of multiplication. The product of a number and its multiplicative inverse is 1. And that's just kind of what we're looking at here on the left. A multiplicative inverse or reciprocal, okay? You're going to hear me say occasionally multiplicative inverse. It's a vocabulary word, or reciprocal also. They are the same thing. They're called different things. And I kind of remember that they're the same thing because they're both two of my favorite words. Multiplicative and reciprocal, they both sound very fun. And I'll give you a tip, too, on how to remember reciprocal as a word so you can picture what that word means. But these are two numbers with the product of 1. Products meaning when you multiply them together, their answer is 1. So, for example, 5 6 multiplicative inverse or reciprocal is 6/5. Because if I were to multiply across, I would end up with 30 over 30, which would be simplified to 1. Think about what happened to 5 6. All it really did was flip around. So what I like to think of is reciprocal as refliprical. Okay, so it's kind of a fun word to say, and it kind of helps you remember what exactly you're doing. And they are the multiplicative inverse, because inverse we think of, opposite. Being upside down is kind of opposite. And it's multiplicative because when you multiply those two things together, you will get a product of 1. So we're going to look at a couple examples, and you're going to try to figure out what is the reciprocal or the multiplicative inverse of these numbers. So really I'm asking myself, what number times this number can I multiply it by to end up with a value of 1? Well, we know that a fraction, a numerator and denominator that are the same, simplify to 1. And we also know that a negative times a negative will get to a positive 1. So if I flip this one around and put 11 over 2, then I would get negative 22 on the top and negative 22 on the bottom, which would simplify to a positive 1. So negative 2/11ths reciprocal is negative 11 over 2. Finding negative 4's reciprocal, what number I can multiply it by to get to 1? Well, we know whole numbers are really written over 1, or integers in this case. So I just need to flip it around, and negative 1/4 would make it my reciprocal. Because if I multiplied across, I'd get, my 4 over 4, which would be 1. So negative 4 is reciprocal. It's negative 1/4. Trying the next two. We see 5 and 1/3 is a mixed number. First thing we have to do with that one is change it to an improper fraction. We talked about this last time. This 5 represents 5 of these. So that's really 5 times 3 plus 1. So this is the same as 16/3. That's the same thing. 16/3 is not its reciprocal. 16/3 represents 5 and 1/3. So now I can flip that around for the reciprocal of 3/16. And I know that because if I multiply 16/3 times its reciprocal of 3/16, going across, I'm going to end up with the same thing. I'd end up with, I think, my 48 over 48, which is the same as 1. Okay? So 3/16 is 5 1/3 reciprocal. Same thing, 3/2. You can try it on your own. See if you can get the right thing. But if I flipped it to 2/3, I'd end up with a product of 1. So this is my reciprocal for 3/2. Okay, so we kind of need to know that reciprocal and that multiplicative inverse before we can move on to the rules to divide fractions. Okay? So we're going to look here at dividing fractions. I might put this up so we can't see everything for now. So some things that we'll do. Same things if we go with that shape, operate, simplify. Dividing fractions, similar to multiplying fractions. There's just a little bit different step. But to divide fractions, we still need them in fraction form. So we need them in fraction form. So what that means is we just need to change any whole numbers and mixed numbers into improper fractions. So again, if I have the whole number 3, I just need to put it over 1. If I have the number 2 1/2, I need to multiply and add and change that to an improper fraction. Okay? So same thing with multiplication there. Next, operating step. Operating step is, I have this here because some of you have learned this as keep, change, flip. Okay? If you learned it as keep, change, flip, great. That'll still work out for you. Otherwise, some rules. You're going to find the reciprocal of the divisor and cancel across. The divisor is that second number. So if I had 5 divided by 2, this number is my divisor, the second number, because it's what you're dividing by. Okay? So that's your divisor. So you can find the reciprocal of that and then cross cancel if you need to. Same as multiplication. So really what you do is change division to multiplication. So in this case, this is a whole number as I know, it would be leave 5 alone, keep, change the sign to multiplication, and flip the second one to its reciprocal. So I can't really cross cancel in this case, so then I would multiply my numerators, 5 times 1, 1 times 2, and then I could go to simplifying in this case. This one says simplify, reduce using common factors. Nothing there, or change into an improper fraction. So that's going to be 5 divided by 2. 2 goes into 5 twice with 1 of the 2 left over. Okay? There's a lot of verbiage, and that's okay. Pretty much the only change from multiplication is that you keep, change, flip. You keep this first number, change division to multiplication, and change the second number, the divisor, to the reciprocal, or in this case, reciprocal of the word. Some of you may have learned this little phrase to help you remember, and it's totally a fine phrase. Dividing fractions as easy as pie, flip the second, and multiply. Okay, nice little rhythm rhyme to help you out. All right, so let's give a couple of these a try using our rules. I may do my checklist on the side again. So if I see 3/4 divided by 1/2, some of you may use the keep, change, flip. You know, I don't care as long as you're showing your work and it makes sense to you. So I'm going to keep that first number. I'm going to change this one. They're already in fraction form, so I don't have to worry about that. Change it to multiplication and change 1/2 to its reciprocal or its reciprocal. So I'm going to flip those numbers around for 2 over 1. I'm going to cross cancel now. And then 1 and 3 don't share any factors other than 1. But 2 goes into 2 once. 2 goes into 4 twice. So now I can multiply straight across. 3 times 1 is 3. 2 times 1 is 2. So now I need to simplify my answer, put it into a mixed number. 2 goes into 3 one time with 1 of the 2 left over. All right? Next up, -4/5 divided by 6/7. One prediction I'm going to make is I know that a negative divided by a positive is going to be a negative. So I'm going to just know that my answer should be negative right away. So they're already in fraction form, no worries there. But now I'm going to, dividing fractions is easy as pie, flip the second number and multiply. On here, it's a little easy for me to write over. Obviously, on your paper, you would want to rewrite it so that it's not so messy for you. See if I can cross cancel anything. And I see 4, 2 goes into 4 twice, 2 goes into 6 3 times. So now I have a negative 2 times 7 is a negative 14 over a 5 times 3 for 15. And since 15 and 14 don't have any common factors other than 1, then I know that it is simplified. So we are good to go there. Okay? All right. A couple more on this end. 4 2/3 divided by negative 3 1/2. Dividing my shape, operate, simplify. This one I do need to shape them. I need to put them in fraction form, in proper fraction form. So 3 times 4 is 12, plus 2 is 14 thirds. That's going to be divided by 2 times 3 is 6, plus 1 is 7. That's a negative 7/6. Before I can start my cross-canceling things, I need to flip the second and multiply. So this is really the same as, I'm going to bring it up here, 14 thirds times the reciprocal of negative 6/7. Now I can do my cross-canceling. 3 goes into 3 once. 3 goes into 6 twice. Remember that negative there. 7 goes into 7 once. 7 goes into 14 twice. Now I can multiply straight across. So I have 2 times negative 2 is negative 4. 1 times 1 is 1. Simplifying would be a negative 4. All right. Now below, I see this one. Looks a little different. I see a whole number. So a little study tip is when divided by a whole number, rename it as an improper fraction first, like we talked about. That's how you put that in fraction form, is by putting it over 1. Okay? So for this one, I'm going to change this to an improper fraction. 2 times 1 is 2, plus 1, so that's going to be a negative 3 halves divided by 12 over 1. I'm going to keep my first number, change division to multiplication, and flip my second number. I'm going to look at my cross-canceling. 3 goes into 3 once. It's a negative 1. 3 goes into 12 4 times. Multiply straight across. Negative 1 times 1 is negative 1. 2 times 4 is 8. So that is my answer. All right, just a couple word problems and then you're on your way. Lena's class is making flags for the school's International Day celebration. She needs 1 1/6 feet of paper for the blue portion of each flag. If the class has a 21-foot roll of blue paper, how many flags can she make? And this is on page 104 in your textbook. There's nice little diagrams there to help you. But what we can do here is that we know how much she has and how much she needs per flag. So since we know how much, we're trying to figure out how many flags she can make out of the total she has. This is the division problem of 21 feet divided by 1 1/6 feet. So first thing I need to do is put these into fraction form. So that's going to be 7/6. And then I'm going to keep the first number and change the sign and flip the second. I'm going to cross cancel. 7 goes into 7 once. 7 goes into 21 3 times. I'm going to multiply across. 3 times 6 is 18. 1 times 1 is 1. And then I'm going to simplify just for 18. And this represented first feet. And this was feet per flag. So really, the feet cancel each other out, and this is going to represent 18 flags. So So you have to be aware of that dimensional analysis and knowing what unit you're looking at. Last one, I suggest maybe you take a chance to read it and try it and then come back to me. It is also in your book on page 104, example 5. So there are 4 people working on a remodeling project. It took them 6.5 days to finish the job. How long would it take 6 people to finish a similar project? So if 4 people each worked 6.5 days, they all worked for that long, the project required 4 times 6.5, and we can call these person days because it was 4 people for 6.5 days. Okay? We then divide the project by 6 people to find out how long it would take that many people to do that. So eventually we're going to divide this by 6. So let's start with that first one. So 4 over 1 times, we want to change 6.5 to an improper fraction, which is going to be 13 over 2. And we can multiply across using our multiplication. 2 goes into 2 once, 2 goes into 4 twice. So 2 times 13 is 26 over 1. So right now we're seeing that it took 26 days. So we're going to divide by 6 for 6 people. And then we're going to find out that how long would it take. And you can simplify that by saying 6 goes into 26 4 times with 2 6 remaining, which simplifies to 4 1/3. And that's going to represent days. Okay? I would take a look in your book on page 104 at that example to look a little bit more closely at the units, okay, and seeing. But seeing the reasonableness, is 4 1/3 a reasonable answer? If it took 4 people 6.5 days to complete a job, 2 extra people would probably shorten the time. So having a shorter number of days seems reasonable. Okay? All right. Don't forget to check things out that you need to review. Do any of the following: rewatch, reread, personal tutors, whatever you need to. Make sure you're doing the NICU. Have notes. Have some things on your notes that say 2 things you learned, 1 thing you're still wondering, and bring those to class.